Welcome back, folks. In today's class, I'm going to talk about the basics from the chapter number 11, and I'm going to take certain examples from exercise 11.1, and we will be talking about the exponents in this topic. Again, this is a very important topic with regards to the basics, so I'm going to start with the basics. So if I write x raised to the power m and outside n, the answer to this one will be x raised to the power m times n. And then the next is, if I write x raised to the power m divided by x raised to the power n, then the answer of this one will be x raised to the power m minus n. And the next will be, if I write x raised to the power m minus m, then the answer of this one will be 1 over x. That's the answer for this one. And then if I write x raised to power m times x raised to the power n, the answer of this one will be x raised to the power m plus n. So I should write these two together. So if this is a division, then it is a subtraction. So x raised to power m divided by x raised to power n, you will subtract m minus n. If they are in multiplication, they will add up. So the next will be, if it is x raised to power m plus x raised to the power n. So please don't start writing it as m plus n. This will be wrong. So don't do it this way. I've seen a lot of students making this mistake. So now we've written a couple of formulas here, and based on these formulas, we're going to try and simplify some questions. And just before I start simplifying the question, one more formula which I wanted to talk about: x raised to the power 0 is equal to 1. All right. So now, if the question given to me is, let's say 5x raised to the power 2, I wanted to simplify this one. So what I'm going to do is, I'm going to distribute 2 with the 5 and 2 with the x also. So this will become 5 raised to the power 2 and x raised to the power 2. And the final answer will be 25x raised to the power 2 for this question. The next is, if I end up writing 5x raised to the power 3 divided by x raised to the power 2, and then outside whole square. Now, before I start opening up the exponent, I will first of all try to simplify within the bracket. So remember the BEDMAS which we talked about in the last class, BEDMAS. So bracket comes first, so I'll first of all try and solve the bracket inside the bracket. So can I simplify within the bracket? Yes, I can surely simplify within the bracket. I can write it as 3 minus 2 x raised to the power x raised to power m divided by x raised to the power n, which is x raised to power m minus n. This is the formula which I have used for this one. And then 5x, this will become, and then raised to the power 2, and this is going to go here, this is going to go here. Now this will become 25 and x raised to the power 2. One more time, I've talked about in the last class also, again talking about this. If there it is written like this, 5 plus x raised to the power 2 square, or if it is 5 plus x raised to the power 2 outside, you cannot distribute it. Please make sure you're not making this algebraic mistake. This mistake, and then another mistake I've seen often students make, is 5 plus x divided by 5. They will cancel this. You cannot do that. To cancel something, if you wanted to cancel the top and the bottom, or means if you wanted to divide them, what you need to do is, you need to have something common from the top. So if it is 5, let's say 1 plus x, it's something like this, then you can reduce them. Okay, so but you cannot just reduce them 5 plus 5x. Let's say if it was 5 plus 5x divided by 5, oh, that's what I can do. No, you cannot do that. Neither you can divide these two. Okay, so you need to take 5 common outside. You will write it 1 plus x and divide it by 5, and then only you can divide. So hopefully this concept is clear to you. You won't make mistake in this concept. All right, now I'm going to take another question. The question looks like x raised to the power 2 y, and then square outside, and then 2 upon x, and then minus 2. Now if I wanted to simplify a question like this, so first of all, I'll try and see if I can simplify within the bracket. No, I cannot simplify within this bracket. Can I simplify within this bracket? No, I cannot do anything within this bracket too. So I'll start distributing. So this will become x raised to the power 2 times 2, and then y raised to the power 2. Basically, if there is nothing, it means there is 1 here. So you are trying to write 1 times 2, and then this is negative on top. So if there is a negative x raised to the power negative 1, you can write it as x raised to the power 1 here. Means this negative, to get rid of this negative, you will bring the term on the bottom. One more time, please. Some students end up writing it like this to get rid of this negative. This negative, you cannot remove it by doing this. So it is in the exponent. That's why I've written it like this. So please make sure you do not confuse yourself. Now, basically what we are doing is we are flipping the terms. So it was x raised to the power negative 1. I can write it as x upon 1 because anything divided by 1 is that thing. So I will flip the bottom on the top and top on the bottom, and then I can write it like this, and this becomes 1 upon x. So same process I'm going to apply on this one. This is negative 2, so I'll write it x upon 2, and this will become positive. Okay, so negative means you will flip the terms within the bracket. Now this will become x raised to the power 4, y raised to the power 2, and this will become x square upon 4. That's the number you're gonna get from here. Now the next one will be, well, one more thing I can do is I can add them up. Also, x raised to power 4 times x raised to power 2, y raised to the power 2 upon 4. So this will become x raised to the power 6, y raised to the power 2 upon 4. That will be your final answer. Okay, let's look into a little more complicated problem. So the question looks like 2a plus b raised to power negative 1, and then square outside. How to simplify with this one, negative outside? So what I'm going to do is I will write it as 1 upon 2a plus b negative 1 square. You can do this step, or you can simplify within the bracket. Actually, I'll simplify within the bracket because that's what we've been doing. So I'm going to write it as 2a plus b, well, not b here, 1 over b, 1 over b, and square outside. That's how I'm going to write it as. Now what I can do is I can take the common LCM, multiply this by b, multiply the top with the b. So the number is going to become 2ab plus 1 upon b, and square outside. And then this, what do I need to do with this one? This was a negative, so I can flip the terms. B will go on top, 2ab plus 1, and then square here. Now I can move this square here. This will become b square, but on the bottom 2ab plus 1, I cannot distribute this square to these two different terms. I have to use the formula on the bottom. So b square upon 2ab square plus 1 square plus 2ab times 1 times 2. Actually, I should write 2 in front. It is 2ab. So a plus b square is equal to a square plus b square plus 2ab. This is the formula I've used here. Now b square upon this, now I can distribute the 2 to all the terms. This is 4a square b square plus 1, and then this will be 4ab. This will be my final answer for this question. All right, now another question. I'm going to take it from the exercise 11.1. I'm going to take a question number 41 here. So v raised to the power negative 1 upon 2t, and then I will put a negative 2 here, and t square here, v raised to power negative 2, and then negative 3 here. And now I'm going to try and simplify this question. How I'm going to simplify this question, because there is a negative 2 here, negative 3 here. So I will flip the terms 2t. Well, before I start flipping the terms, I can move this negative. I can get rid of this negative by moving the term down. Okay, this negative only belongs to v. this negative 1 does not belong to 2t. So this is out, the negative 2 is outside the bracket. This negative belongs to the top term, also to the bottom term, but the negative 1 belongs to only to the top term. So 1 upon 2 tv, and then negative 2, and then this will be t square, and v square on, we're going to come on top, negative 3, and this will be 1 on the bottom. And now I'm gonna rearrange, well, I'm gonna try and get rid of the negative sign. So 2tv means this will come on top and 1 will go on the bottom, and then square, and this will become 1 upon t square v square, and 3 on top. So this will go here, 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 and now this will go here, here, here. So 2 raised to the power 2 t square v square, and this will be 1 cube, which is 1. This will be t raised to power 2 times 3, and v raised to power 2 times 3. Here, which formula I've used, x raised to power m times n is x raised to power m mn. All right. So this will be equal to 4 t square and v square, and then this will be 1 upon t to the power of 6, v to the power of 6, and then this is gonna be 4. This 2 you can write it as with this t, so you will write it as t raised to power 2 minus 6 and v raised to power 2 minus 6, and then 4 t raised to the power negative 4, v raised to power negative 4. So please don't stop here, because the final answer, in final answer there should not be a negative exponent. So 4 t will go on the bottom, t raised to power 4, v raised to the power 4. That will be my final answer to the given question. All right, so now let's look into one more question, which is kind of similar to, not exactly similar, means a little different from this one, but on the exponents. So if the question looks like negative 7x raised to the power 0, anything raised to the power 0, answer is 1, period. Okay. Now 5 raised to the power 0 times 5 raised to the power negative 3. So how are you going to solve it? 5 raised to the power 0 means anything raised to the power 0 is 1. Anything raised to the power 0 is not 0. Please remember this thing. Anything raised to the power 0 is 1. So x raised to the power 0 is 1. X times 0 is 0. So these are two different things. So this will be a 1 times, so let's do it here, 1 times 5 raised to the power negative 3, and then this will become 1 times 1 upon 5 to the power of 3. So 1 times 1 is 1, 5 to the power of 3 is 125. That is the number you're gonna get from here. Okay, now let's look into another question. If the question is 3x plus 2y raised to the power negative 2. This is question 36 I'm doing. The previous one was question, this one was 22 from the book, and this there was another question. This one, I don't remember which question I took, but anyhow, I'll now do this one, the one in front of us. Now, can I distribute this? No, I cannot distribute this one. Can I simplify within the bracket? No, I cannot. So I'll write it 3x plus 2y raised to the power 2. And now I can open up the bracket. This will be 3x square plus 2y square plus 2 times 3x times 2y. That's how I'm going to write it. So a plus b square is equal to a square plus b square plus 2ab. That's the formula I've used. So this will be 1 over, this will be 9x square plus 4y square plus 2 times 2 is 4 times 3 is 4 times 3 is 12, 12xy. That will be my final answer to the question. All right. So in any one more question I'll do. So this is 2 upon n raised to the power 3 raised to the power negative 3. How I'm going to simplify? Cannot simplify within the bracket, so I'll take the exponent now. So n raised to the power 3 over 2, n raised to the power 3, and then this will distribute itself over the number. So n raised to the power 3 times 3, and 2 raised to the power 3, n raised to the power 3 times 3 is n to the power of 9, and this is not 2 times 3, this is 2 to the power of 3, which means n to the power of 9, 2 times 2 times 2, 2 times 2 times 2, 2 to the power of 3. Okay, so n to the power of 9 over 8. That's my final answer. All right, so hopefully you were able to understand some basics of the exponents, and I'm going to continue talking about some more basics from exercise 11.2 also, which will be a little more complicated with the fractional exponents. So if the question has a fractional exponent, so for example, if I write down 64 raised to the power 1 over 2, now this fraction means it, you can also write it like this, square root of 64. If it was 64 raised to the power 1 over 3, it means it is cube root of 64. If it was 64 raised to the power 1 over 4, it means you are looking for fourth root of 64. Now the idea of the means the trick to solve this fractional exponent is whatever the base is, this is the base, whatever the base is, uh, you should try and convert it into such way that you can cancel out the fractional exponent. So 64, what number I can convert 64 into so that I can cancel out the fractional exponent with that? I can write 64 as 8 raised to the power 2. I'm going backwards and then multiply by 1 over 2. So 8 raised to the power 2 times 1 over 2, which gonna give me 8 as my final answer. So answer for 64 raised to the power 1 over 2 will become 8 as my final answer. Now, if it was 64 raised to the power 1 over 3, this was the question, I would have written it as 4 raised to the power 3 and times 1 over 3. So this will become 4 times 3, 1 over 3 cancels out, the final answer will become 4. So that's how you're gonna simplify these questions. Now, another thing, if I write it as 64 raised to the power 5 over 5 over 2. Now, whatever is in the denominator of the exponent, mark my words, denominator of the exponent, I'll try to convert this thing into that form so that I can cancel that denominator from the exponent. So 8 raised to the power 2 and then 5 over 2. Now this will cancel out. So final answer will be 8 to the power of 5, which will be 32768. Final answer. Okay, so that's how you're gonna simplify this question. Now another question I'm gonna do 16 raised to the power 3 over 4. Now I'll encourage you guys to pause the video and try and do it by yourself. So welcome back. And so what you're going to write for this question is, you will write it as 2 raised to the power 4 and 3 over 4. You cancel these two terms, 2 raised to the power 3, which is equal to 8 as my final answer. All right, so my laptop battery is going down almost, but I'll try to sneak in one more question. The question is 8a square b raised to the power 4 1 over 3, and then you will write it as 8 to the power of, I can distribute this to all the terms, 8 to the power of 1 over 3, and then a to the power of 2 times 1 over 3, b to the power of 4 over 3. And you can also write it as times 1 over 3. So 8 to the 1 over 3 will become 2 to the power of 3 times 1 over 3, and a to the power of 2 over 3, you cannot do anything about it, b to the power of 4 over 3. So this will cancel out, 2a to the power of 2 over 3, b to the power of 4 over 3. That will be your final answer for this question. Now, one last question which I'm going to do, which is little tricky to solve, but we're going to try and do this one. 4 negative 3 over 2, and then x raised to the power 2 over 3, and y to the power of negative 7 over 4, and then I will divide it by 2 to the power of 3 over 2, and x to the power of negative 1 over 3, y to the power of 3 over 4, and then this is 2 over 3. Now how I'm going to simplify this question? So first thing I need to do in this kind of a question is I need to seek out if I can cancel some of the terms within the bracket. So I will write this one as 2 raised to the power 2 times negative 3 over 2. Right, and then on the bottom I cannot do anything. Actually, rather than writing it like the yes, I have to write it because this is 2, this is 4, I can't do anything. 2 raised to the power 2 times negative 3 over 2, and this is x to the power of 2 over 3 plus, because this is minus on the bottom here, this will go on top, will become minus and minus plus, so something like minus 1 over 3 when you're going to take it on top. So it's like x raised to power m divided by x raised to power n. What you write, x raised to power m minus n. That's what I'm doing. So same thing I'm going to do on the next one. 7 4 and minus 3 over 4, and then 2 over 3 here, and then there was 1 2 3 over 2 was left over here. This I haven't moved still. I can cancel these two, and I'm left with 2 raised to power negative 3 and minus 3 over 2. Now I can write it, now I can bring this on top, and then x raised to the power 3 common base, and negative negative will become plus, this will become 3, and y, this will become 4, and negative 7 negative 3 will give me negative 11, and then 2 over 3. Now this will become 1, and this thing will become, I'll place 2 bar on the bottom, multiply this with 2, so this will become 2 to the power of negative 3 times 2, well 3 times 3, oh wait a sec, 3 times 2 shall I say, 3 times 2 is 6, negative 6 over 2 minus 3 over 2, and now this is x, y to the power of 11 over 4, which I can bring it down, y to the power of 11 over 4, and then 2 over 3 is outside still. Now I'm gonna simplify the exponent of 2 on the bottom, negative 9, because 6 plus 3 is 9, and then x, and then divided by y to the power of 11 over 4, and this is 2 over 3 outside. Now I can start opening up the exponent because I cannot further simplify within the brackets. So I will multiply this here, this will go here, this will go here. So let's do the math. So 2 to the power of negative 9 over 2 multiplied by 2 over 3, x to the power of 2 over 3, and then y to the power of 11 over 4 times 2 over 3, and then cancels out, this will be negative 3, and then 2 to the power of negative 3, x to the power of 2 over 3, and then y divided by y to the power of 11 times 2 is 20 each. Well, I can reduce them to, so 11 over 6, and this will go on the bottom. I can write 2 to the power of 3, y to the power of 11 over 6, x to the power of 2 over 3, and that my final answer will be 11 over 6, x to the power of 2 over 3. That will be my final answer. I think I might have made some mistake in the y term, because y term they are writing it as 5 over 3. I'm not sure where did I make a mistake on the y term. I will quickly check my y term here. y was 7 over 4. Quickly checking, negative 7 over 4 and negative 3 over 4. So all right, why I'm writing 11 I don't know, I'm a stupid. Negative 10, I should have written it. So negative 10 over 4, I can write it as negative 5 over 2 also. So I will write it as negative 5 over here, positive 5, because I brought it down. So positive 5 over 2, and then here I will write it as positive 5 over 2, and then here I will write it as positive 5 over 2, 5 over 2 multiplied by 2 over 3, and then I can reduce them, and then this will become 5 over 3 as the number. So that's more correct. 5 over 3. 5 over 3. So hopefully you understood how to simplify the exponent questions. Okay,